So the big picture for this lesson is analyzing graphs of polynomial functions. And we're going to be looking at zeros of these functions and turning points of these functions. So I have my calculator ready, and I have a polynomial function already entered, 3x to the third power minus 2x squared minus 8x minus 4. I'm going to press graph, and this is a standard window. And since I know end behavior, I know that the graph is coming up from the left here, and then here's a turning point, and then down, and then here's another turning point just barely off the screen, and then up, and here's a 0 right here, and then it continues to go up. Now there are some things that I know based on my knowledge of zeros and polynomials. The degree is 3, so there must be 3 zeros, including complex zeros and repeats. And there's only one real zero. That means the other 2 zeros are complex. And I know there's only one real zero because there's only one x-intercept. I also know there aren't any real zeros that are repeated, because if there were, there would be a turning point on the x-axis, and there are no turning points on the x-axis. So let's calculate a turning point. And this first turning point here, this is called a local maximum because it is the highest point compared to the points around it. So I'm going to go to second and then calc, and then I'm going to calculate a maximum, which is 4, local maximum. So first I need to move to the left of the turning point. That's the left bound of the interval. It's going to calculate the maximum. Then the right bound, move to the right of the turning point. Enter one more time. And there are the coordinates of the turning point, negative 7.46 or about negative 7.5 for the x value, and the y value is negative 0.39 if you're going to round that. So that's how you calculate a local maximum. Now the local minimum doesn't quite appear on the graph, so I'm going to change the window. I'm going to change the y min to be, let's say, negative 15. Now I can see the minimum. So local minimum. And see, I'm to the left of the minimum here, so I'm going to hit enter, and then move to the right of the minimum. Enter. Enter one more time. And the local minimum is about 1.19 for the x value and about negative 11.296 or 11.30 for the y value. So if you want to calculate an x-intercept or a 0, go second calc and then 0, and it's the exact same strategy. You want to be to the left of the 0, enter, move to the right of the 0, enter, enter one more time, and the 0 is about 2.17, and then of course the y value is 0. So that's what you're going to be doing in this lesson. You're going to be graphing polynomial functions, you're going to be finding zeros and turning points. And also there's an interesting application of polynomial graphs called the box problem. You'll be taking a look at that as well. That's the big picture.